Hey guys, what's up? This is Manoj sir, and in this video we are going to solve application part of Laplace transform, second problem. Very important problem. So let us start. The problem says solve t into y double dash plus 2 into y dash plus t into y equals to cos t, given that y at t equal to 0 is 1. Okay. So here, since we have y of double dash, y of dash, so we are going to use derivative property of Laplace transform, but before that we have to go for multiplication property also. So taking Laplace transform on both sides, you will get Laplace transform of t into y double dash plus twice Laplace transform of y dash plus Laplace transform of t into y equals to Laplace transform of cos t. Okay. First of all, we will go for multiplication property. Okay. Which will give you, since the power of n is 1, in the case of in the power of t you have only 1, so we will get first derivative, okay, minus first derivative of this, that is Laplace of y double dash, plus this is twice Laplace of y dash. This is here you have t to the power 1, that means we'll go for first derivative. Okay, that is, on applying multiplication property you will get minus of first derivative of Laplace of y equals to Laplace of cos t. Okay, fine. Now we will go for derivative property, which says, here we have derivative property of Laplace transform, that is, if Laplace of f of t equals to f bar of s, then Laplace of nth derivative of f of t equals to s to the power n Laplace of f of t minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash 0 minus s to the power n minus 3 f double dash 0, and so on. Okay, now here you have n equals to 2, so let us see what it becomes. Minus of d upon ds of, here you have n equals to 2, so s to the power 2 Laplace of y minus s y of 0, then minus this will become 1 and this will become y dash 0. So this part is solved. Now come to this part, that is twice, here the power of here you have first derivative of y, that is y1, or you can say y dash. So here s to the power 1, okay, Laplace of y minus here s to the power 1, then here it will be s to the power 0, which is 1, and you have y dash, sorry, y of 0. Now this part is over. Now come to this part, that is minus of d upon ds of Laplace of y, and Laplace of cos t is how much? S upon s square plus 1. Okay, fine. Now we'll be opening this bracket, or we can say we will differentiating this term. Okay, these three terms we will be differentiating, but in this case you will be having multiplication property of differentiation because of s square and Laplace of y. Here y of 0 is how much? 1. In the question itself it is given that y of 0 is 1, y of 0 is 1. So here minus of this will be s square d upon ds of Laplace of y, okay, plus Laplace of y into d upon ds of s square will become twice s. Okay, so this part is over. Now come to this part, this is minus d upon ds of s will be 1, and y of 0 is also 1, so here it is 1 Now come to this part. Fine. This part is a constant, so d upon ds of y dash 0 will become 0 because of this, because this is a constant term. Now come to this part, plus twice s Laplace of y minus, this is 1, so 2 into minus 1 will be minus 2. Now come to this part, that this is minus d upon ds of Laplace of y, which is equals to s upon s square plus 1. Okay, now we will be opening this bracket. Okay, this is minus s square d upon ds of Laplace of y minus plus minus twice of s Laplace of y minus minus plus. Okay, plus this is plus twice of s Laplace of y minus 2 minus d upon ds of Laplace of y equals to s upon s square plus 1. Now here if you see, this is a negative term, that is 2 minus of 2s Laplace of y. Here it is positive term, that is positive of 2s Laplace of y. So these two will get cancelled. Now if you compare the coefficient of d upon ds of Laplace of y, here you will see minus of s square, and here it is minus 1. So taking minus common, you will be getting s square plus 1. Okay, here it is plus 1 and here it is minus 2. So it, on adding 1 and minus 2, will get minus 1. Take this minus 1 to the right hand side, you will get plus 1. So plus 1 plus s upon s square plus 1. This is positive 1, this is minus 2. You will get minus 1. Take that minus 1 to the right hand side, we will get positive 1. Okay, now again taking this s square plus 1 to the right hand side, you will get minus of d upon ds of, we can write Laplace of y as f bar of s. Okay, fine. This becomes 1 upon s square plus 1 plus this will become s upon s square plus 1 whole square. Okay, now taking inverse Laplace transform on both sides. Okay, now taking inverse Laplace transform on both sides, what we will get? Inverse Laplace transform of minus d upon ds of f bar of s equals to inverse Laplace transform of 1 upon s square plus 1 plus inverse Laplace transform of s upon s square plus 1 whole square. Okay, now this is going to be t into y. Okay, this part, okay, inverse Laplace transform of 1 upon s square plus 1 will become 1 upon 1 times sine t. Okay, here we have the formula. Yeah, this formula, that is inverse Laplace transform of 1 upon s square plus a square becomes 1 upon a times sine at, and if you compare this with this, you will get a equals to 1. So here it will be 1 upon 1 times sine t, that is 1 upon 1 times sine t. Writing this as it is because we are going to find separately this inverse Laplace transform separately by the help of convolution theorem. Okay, s square plus 1 whole square. Now t y equals to sine t plus inverse Laplace transform of sine s upon s square plus 1 whole square. Okay, now let's suppose this is my equation number 1. Now we are interested in finding the inverse Laplace transform of s upon s square plus 1 whole square by the help of convolution theorem. Okay, solving inverse Laplace transform of s upon s square plus 1 whole square, which can be written as inverse Laplace transform of s upon s square plus 1 into 1 upon s square plus 1. Okay. Now let's suppose this is my f bar of s and this is my g bar of s. So let f bar of s equals to s upon s square plus 1 and g bar of s equals to 1 upon s square plus 1. Okay. Now taking inverse Laplace transform on this side and this side, you will get inverse Laplace transform of f bar of s, which equals to inverse Laplace transform of s upon s square plus 1, s upon s square plus 1, which becomes cos t, which is nothing but your f of t. Similarly, if you see inverse Laplace transform of g bar of s, which is equals to inverse Laplace transform of 1 upon s square plus 1, this becomes 1 upon 1 times sine t, which is equals to sine t, which is nothing but your g of t. Okay. Now we will be applying convolution theorem. So by convolution theorem, we have, since, okay, as per convolution theorem, if Laplace of f bar of s equals to f of t and Laplace of inverse Laplace transform of g bar of s equals to g of t, then inverse Laplace transform of f bar of s into g bar of s equals to integration 0 to t f of u into g of t minus u du. Okay, fine. Let us try to solve this part, which is inverse Laplace transform of s upon s square plus 1 into 1 upon s square plus 1 equals to integration 0 to t. This is cos t. In place of t, write u. That is cos u into, here it is sin t, and in place of t, write t minus u. Sin of t minus u du. Okay. Now multiplying 2 and dividing 2. Here it will give you formula of 2 cos a into sin b, which gives you sin a plus b into, which gives you sin a plus b minus sin a minus b. So applying that formula, you will get half integration 0 to infinity, 0 to t. You will be having sin of, here it is, a is u and b is t minus u. You will be having u plus t minus u, because we are going for sin a plus b, a plus b. Okay. Now this is minus sin of a minus b, a is u, minus of this, that is t plus u. Fine, this part. Okay. Now proceed. Here u gets cancelled, so we are left with integration 0 to t sin of t minus sin of 2u minus t. Okay, du. We are integrating this with respect to u. Okay, half. When you integrate sin t with respect to u, this becomes constant. So sin t u, limit goes from 0 to t, minus, okay, since sin contains u, okay, now integration of sin becomes minus cos, so it is minus plus cos of 2u minus t, and the coefficient of u is how much? 2, so it is upon 2. Now limit goes from again 0 to t. Okay, fine. Now proceed. Half, this is sin t minus 0. In place of u, upper limit is t and lower limit is 0, that is t minus 0. Now come to this part. Half is taken outside. This is cos of, if you put upper limit, that is t, in place of u, you will get 2t minus t, that is t. Okay, minus if you put lower limit in place of 0 u, if you put lower limit, that is 0, in place of u, you will get cos of minus t, which is again cos t. It means cos t. Fine, these two terms get cancelled. Okay, 1 upon 2, this is t sin t. Okay, so we get inverse Laplace transform of s upon s square plus 1 whole square as how much? Half t sin t. Okay, fine. Now from equation number 1 we have, yes, equation number 1 is this. So here we can write from equation 1, t into y equals to sin t plus, here it is half t sin t. Okay, now taking sin t common, you will be having 1 plus half t sin t, which is nothing but t into y, and this is my final answer. Okay, so if you like this video, then don't forget to hit the like button, and please share this video with your friends. Thank you so much.